Bismillahirrahmanirrahim. Assalamu alaikum dear viewers, I am Dr. Noshin Afshan and you are watching Dr. Noshin Afshan YouTube. I hope that all of you would be fine and I am thankful to you for watching this video. To watch more videos, please subscribe my channel and press bell icon. So our today's lecture is about structure of carbonyl compounds, where we will consider this carbonyl compound in general as an example. But prior to discussing this carbonyl compound, we will discuss the structure of water molecule for the sake of simplicity. So, as you know that the atomic number of oxygen is 8 and the electronic configuration of these oxygen atoms at its ground state is 1s2, 2s2, 2px2, 2py1 and 2pz with 1 electron. Here, these 4 atomic orbitals, one orbital of this 2s and 3 degenerate p orbitals, that are 2px, y and z. These intermix to form 4 sp3 hybrid orbitals, where 2 of them would have 2 electrons and the other 2 would be partially filled. So now these 4 hybrid orbitals would orient themselves in a tetrahedral geometry that looks like this. Here, this is the paired one and this is also the paired electron. So, here this sp3 and this sp3, these 2 sp3 hybrid orbitals would have the electron pairs in them and rest of the 2 sp3 hybrid orbitals would have 1 electron. As you know that here in the case of water molecule, there are 2 hydrogen atoms attached with the oxygen and there are 2 lone pairs with the oxygen atom. So here there is a 1 lone pair and here there is the second lone pair of electrons, and these hydrogen atoms, here this sp3 hybrid orbital would be overlapped with the 1s orbital of the hydrogen atom, forming a sigma bond, and similarly this would also behave likewise, and in this way it would show a tetrahedral geometry. Now what happens in the case of this carbonyl compound? So in the case of this carbonyl compound, as you know that here the carbon is bonded to oxygen via double bond, that means there is 1 sigma bond and 1 pi bond, and it shows that this carbon atom would have the same behavior as that of alkenes, because here there is also a double bond. So same like alkenes, this carbon would show sp2 hybridization, and we draw the sp2 hybrid orbitals of the carbon atom that are like this, and each of these sp2 hybrid orbitals contain 1 electron, and there is also an unhybridized 2pz orbital with the carbon atom. So now here there comes that the oxygen atom has 2 lone pairs, 1 sigma bond and 1 pi bond with the carbon atom, and these 2 lone pairs and 1 sigma bond. For this purpose, here it would show sp2 hybridization, and it would give 3 sp2 hybrid orbitals, where 2 of these sp2 hybrid orbitals would be completely filled and one of them would have 1 electron. and this 2pz orbital would be unhybridized. So in this case, this is the oxygen atom, and in the case of these sp2 hybrid orbitals, one sp2 hybrid orbital would overlap with the sp2 hybrid orbital of the carbon to form a sigma bond, and the other two would be aligned in this way, and these would be completely filled. These are also sp2 here. Okay, and there is one unhybridized orbital, that is 2pz. We will draw this like as here. This is the 2pz orbital of the oxygen atom. So now this unhybridized orbital would overlap or would interact with the unhybridized 2pz orbital of the carbon atom to form a pi bond, and this pi electron cloud would be shown above and below the sigma bond. So now the situation over here with these sp2 hybrid orbital of the carbon atom becomes, if it is the aldehydic, then one bond of this carbon atom will be with the hydrogen atom. Let's suppose if this is with the hydrogen atom, then it would be with 1s orbital of the hydrogen in the case of aldehydes, and here there would be any other like CH2 or CH3. Then as you know that all of these alkanes would show sp3 hybrid orbitals, and there would be an sp3 hybrid orbitals overlapping here. And if here it is still CH3, then despite of this 1s orbital of the hydrogen atom, it would also overlap with the sp3 hybrid orbital of the other carbon atom. So in this way, here along the both of these sides, you may categorize or you may draw the orbital diagram same like alkanes. So please let me know in the comment section that how much these videos are helpful to you. So thank you very much for watching the video. Please subscribe my channel and press bell icon. Allah Hafiz.